Okay, people, we'll just finish off what we meant to do on Thursday so that you can watch this in your own time rather than try and catch up on Friday. So this is where we were at, the slide we were up to last time you watched that video. I just put in a slide here, so if you want to pause and just have a read through, that's from the subject outline we'll be covering for the last couple of slides here. Okay, this is a good video, so learning a bit about the cation exchange process in plants. So the fact that plants produce those hydrogen cations, and that allows them to exchange those hydrogen cations with other cations that it actually needs to grow. And it also, so this is all follows into page 306 to 308 of the Essentials book, if you have a look through there. Also talks about, let me look, so yeah, cation exchange capacities, another term which is in that video. So different soils in different regions have different levels of cation exchange capacity. So the higher the CEC, the less fertilizer, or the less often that you need to maintain that soil and add fertilizer and reneutralize, add more nutrients to the soil. Okay, so such as those other elements. So that's in that, I would watch that's about 5 minutes. So this, from that we follow on. So here we're talking about the importance of, I see the pH in soil. So here we've got, so hydrogen ions bound to clay. Okay, on this side, and here we've got our metal cation in aqueous form, so that's in equilibrium with hydrogen ion in aqueous form, and the metal which we ideally want bound to that clay. Okay, so if we increase the amount of hydrogen ions, so we're decreasing the pH of the soil, this will drive the equilibrium to the left. Okay, so from right to left. So what's going to happen to the metal ions in the soil? So maybe just pause, have a think about that, and then continue. So obviously when we do that, it's shifting to the left, so we're getting more of the metal ions that the roots want to access in that aqueous form, which that has some advantage where it's more available for the plant to uptake initially, but that problem with that, it can be leached out. So if you look down the bottom here, so those nutrient cations are susceptible to leaching out. So if you get further rain, it basically washes out those metal cations that are dissolved in the soil water in that particular stage. Okay, so we're shifting it to the left, so we're losing all those great metals of potassium, calcium, magnesium that are bound to the clay, which the plants can exchange with, and they're becoming aqueous and possibly leaching out. Also have that issue with aluminium, can be released into soil water through that process, which is a bit toxic to plants. So that's no good. Next term we'll talk about, so we're talking about salinity and salicity. So salinity is the measurement of amount of salt or amount of sodium ions in solution. So if salts are not leached out of the soil by rainfall, the effective drainage salinity can be an issue. So certainly an issue in South Australia. So accelerated by human activity. So land clearing is a big thing. So farming, land clearing, replacing sort of annuals with perennials, plants. So that when it does actually rain, that water causes the salt deep within the subsurface to actually leach up into the surface and cause all sorts of problems for that top layers of soil and for the plant life as well, as we'll see. So that's salinity. Salinity is the amount of sodium that is in solution. If we go back, okay, it's the amount amount of sodium dissolved in soil. And next term we need to know is sodicity, so it's the measure of sodium that's bound to the clay surface. Okay, so here we've got, if we've got a high saline content soil, okay, in contact with that clay, which is magnesium adsorbed onto that clay surface, then what can happen is that exchange process can cause, if it's shifting to the right, those sodium ions to actually be bound to the clay, to get adsorbed onto the clay, exchanging with the magnesium, so the magnesium becomes aqueous and then obviously leaches out as well. But what this actually does as well is that because we've got that sodium now bound to the clay, it actually can cause issues with the attraction forces between those soil layers, and the soil actually starts to weaken and break down, and you get things like erosion occurring in that situation. So yeah, soil dispersion, the collapse of the soil structure, is a big issue with sodic soils. Okay, this is a video, another about 5 minutes, so that goes right into salinity issues in sodic soils and gives you some really good graphic images of what sodic soils look like. So explains it quite well. Have a look at that one. And we get on to, alkaline soil. So many parts of SA are quite alkaline. So pH increases, solubility of many nutrients is reduced or compromised. So here you've got an example of iron. So at a pH of 4, it's quite soluble, so 100 parts per million. Once you start bringing the pH only by 2, from pH 4 to pH 6, solubility drops considerably, actually from 100 parts per million down to 0.01 parts per million. So the availability of iron is reduced considerably. So, and once you start getting above 7.5, then the levels of some of those metals is too low to sustain healthy plant, healthy plants. And that's across many of the cations that plants need to thrive. And many of those alkaline soils contain low amounts of magnesium, and also that causes that problem as well. Have low. Okay, so that completes this topic. So basically topic 4, so 4.1, 4.2 and 4.3 are now done. So make sure you have a look at those, back at those videos right throughout the PowerPoint. There's a couple other ones, so have a look through those, and also read through the Essentials book. Obviously, just keep reading through that, trying to keep ahead as well. So just to back up your learning. So I've given you your formative test, so work on that, and we'll catch up with you in the middle of the break. But have a great break anyway. Okay, cheers.